Okay, this is going to be the review for statistics and combinations, permutations, and algebra 2. The first question says, does a graph appear to be normal? Here's how it's not normal. This is going to be no, because this doesn't equal this. The mean has to equal the median, which has to equal the mode. Okay? What is the z-score of the test score of 97%? Okay? All right, so our z-score, the way we figure that out is z is going to be equal to the item minus the mean, which is 77, divided by the standard deviation. Okay? So the key thing is when you type that in, all right, go ahead and figure out the top part first. All right, and then divide it by the bottom. Okay, so my z-score there is 1.45. Okay, in general, what does it mean to have a z-score that is negative? That means it's going to be less than the mean. Your item is. Okay, so whatever you're comparing, if it's below the z-score, if it's got a negative z-score, it's below the mean. If it's normally distributed, what z-score will always, what will the mean z-score always have? That would be 0. Okay, because like if there was 77 minus 77, okay, that'd just be 0 over 13.7, which would be 0. If in a normally distributed set of data, what percent of scores will be below a z-score of 1? Okay, so, all right, our empirical rule tells us, and I don't have a lot of room for this, I might have to draw it down here. That's not good. Okay, draw a smaller curve. Okay, so we got 34 and 34. I just don't have enough room for this on this section. I'll come back to that question. Okay, normally what that's going to be is 0.15, 0.235, or 13.5, 34, and 34. All right, that will be less than, if you add all those numbers up, okay, you can use your calculator to do that. If I had enough room, I would draw out the curve for you, but 13, 34, 34, because so basically 84% of the data will fall below a z-score of 1, okay? And you can also get that by looking at your z-score chart. If it's normally distributed, what is true about the relationship between the mean, median, and mode? They're all the same. Okay. What is the total area under a normal curve? 1 is the answer there. Abby and Bobby got their z-scores for SAT. Abby is negative 1.2. Bobby is 0.7. What does that tell you about Bobby and Abby and Bobby's SAT scores? Okay. Abby did better than Bobby. That's not true. Bobby did better than Abby. He did better than the mean. Abby is closer to the average than Bobby. That's not true as well. Bobby's closer to the average because his z-score is closer to the mean. Bobby did better than most people. That is also true. Okay, because he's better than average. Describe how the mean and standard deviation affect the graph of a normal curve. Okay, I'm going to skip that problem for right now. You can get that in class. But basically, the standard deviation, if it's skinnier, okay, it's less standard deviation, and if it's wider, it's more standard deviation. Okay, right? Because it's more spread out between the those terms. Okay, the national aviary has 236 birds. The average weight of a bird is 20 ounces with a standard deviation of 1 ounce. Approximately how many birds at weigh over 121.5 or 21.5 ounces? Okay. All right. So what I'm going to figure out here, all right, is I'm going to figure out the z-score for 21.5. All right. So I'm going to figure out the probabilities of both sides. First thing I'm going to do is I'm going to figure out the z-score. So that's minus the average divided by the standard deviation, okay? So that's going to be 1.5 divided by 1. So my z-score is 1. So what I do is I go to my z-score chart. All right, I'm going to find 1.5, I'm sorry. Okay, I'm going to find 1.5. And what that says is it's 0.9332. Okay, now what that means is to the left here is 0.9332. Okay, all right. To figure out the other side, I just do 1 minus 0.9332. All right, that gives me 0.0668. All right, and then it's 2 zeros. No, just 1 0. 0.0668. 0.0668. Okay, so the question I have to ask myself is, all right, when it says over, that's going to be this side. So I'm going to take this number and I'm going to multiply by the number of birds. Okay, so I'm going to get 0.0668 times 236 birds. All right, so about 15 birds are going to be over that amount. The average calf weighs 90 pounds at birth with a standard deviation of 9.2. The Dusty farm will have 300 calves. How many calves will weigh between 75 all right, and 130? Okay, so I'm going to make a big curve here. All right, so obviously 75 is a smaller number, so I'm going to start with that one. Okay, 130 is going to be over here. Okay, now what I'm going to do is I'm going to figure out the z-score of 75. Okay, so that's going to be 75 minus 90 pounds with a standard deviation of 9.2. Okay, so what I got there is 75 minus 90. Okay, divided by 9.2. All right, so my z-score is negative 1.63. So what I'm going to do is I'm going to look on my chart, and negative 1.63 is going to be at 0.0516 for this side. 0.516. Okay? All right, so now what that means for me is all of the rest of that, all right, 1 minus 0.0516. Oh, whoops. 1 minus 0.0516. Meaning the rest of it has got to be, so all this over has got to be 0.9484. So all this over here is 9484. So everything over that way. Now, all right, I got to look at what the 130 says, okay? Well, 130, I got to find that z-score. That's 130 minus 90 divided by 9.2, okay? 130 minus 90 divided by 9.2, and I get 4.34, okay? So that's basically going to be off the chart there, okay? So basically that's going to be basically 0%, okay? Because if you look at your Z chart, it goes off at, so basically 0.9998, all right? So only 0.0002 would be over on that side, okay? So what I got to look at is what is going to be between these two, okay? What is going to be between these two? Well, here's how I can figure that out, all right? I know what's to the left here, 1 minus 0.0516, okay? And I'm going to subtract another 0.002, so, wait, one more zero actually. So the amount in there is 9.9482, okay? That's my probability. There are 300 calves, so I'm going to take that amount and multiply by 300, okay? All right, times 300. So the number of calves is 284, okay? All right, 284. All right, moving on to the next one. A standardized curve has a mean of 425 and a standard deviation of 50. Draw a picture of the normal curve showing 3 standard deviations to the left and right. Shade the area to represent between 375 and 525. Okay, so this is actually pretty easy. Okay, All right, my mean is 425. I'm right here. All right, so what I would do is I'm going to add 50 to this number, would give me 475. Add 50 to that one would be 5 1/4. Add 50 to that one would be 575. Okay, that's 1 standard deviation, 2, and 3. Okay. All right, going back the other way, this would be 375, -1 standard deviation. 325 is -2 standard deviations, and 275 is -3 standard deviations. Okay. All right, shade the area that represent between 375 and 525. So what I would do is I would just shade these. Okay, those are between. Determine the probability that an event has a z-score between those two. Okay, so what I'm going to do, what's nice is here is they've actually given me the z-scores. Okay, so I don't have to go find them like I did in the previous problem. All right, so at -1.10, all right, the z-score here, this is going to be 0.1357. Okay, all right. All right, so that's going to be 0.1357. All right, for the other one, I'm going to go for 2.52. Okay, all right, 2.52 tells me that this all the way over here, all this stuff all the way over, is going to be 252 would get me to 0.9941. Okay. 9941. Now, I already know this is here, so all I need to figure out is this. So that's a simple subtraction problem. Okay, that's a simple subtraction problem. So I got 0.99.
Can I please have a custodian to the second floor cafeteria?
41 minus my 0.1357. Okay, so what that tells me is that area in between is 0.8584. Okay, so the whole thing over there represents that. All right, so it says draw and shade the correct area to help you find your answer. So this would be my answer with my probability being 0.588584. Okay, the scores of a national assessment of educational progress in 12th grade. Approximately normally distributed. The max score on the test is 600. The mean of a recent score is 320. The standard deviation is 38. Determine the probability that a randomly selected student who took the test had a score greater than 385. Okay, so what I'm going to do is I'm going to pick out, all right, 385, which would be over here. Okay, so what I want to do is I want to find the z-score first. Okay. All right, so if I did that, I would have 385. Oh, whoops, didn't put my marker down. Let me clear that out. All right, so 385 minus 320 divided by 38. Okay, that gives me a z-score of 1.71. So what that tells me, all right, if I go to my z-chart and find 1.71, that's 0.9564 would be on this side. To figure out what would be on the other side, I could do 1 minus 0.9564. All right, that's going to be 0.0436. 0.0436. And now I'm going to analyze the question. It said determine the probability that a student who took that test had a score greater than that. Well, the greater side is over here, so my probability is 0.0436. Okay? Determine the probability a random student scored less than 300 or greater than 400. Okay, this can be a little bit tricky, okay? Because what I want to do is I want to find what 300 is, I want to find what 400 is. All right? So I got to find both z-scores. So 300 minus 320 divided by 38. Okay, over here I'm going to do 400 minus 320 divided by 38. Okay, so I want to figure out the z-scores for both. All right, I'll put this right in the middle so I can see both. 300.
Students who are performing in the International 9, please report to the auditorium at this point. Thank you.
Okay, negative 0.52. Negative 0.52. So if I go to my z-score chart and look up negative 0.52, it tells me that this area right here would be 0.3015, okay? All right, which means this whole area over here, Okay, well, let's go ahead and find what the 400 would be. 400 would be, let's do 400 minus 320. Okay, it's 80 divided by 38. Okay, 2.10. Okay, so I'm going to find the z-score of 2.10, and 2.10 tells me that all of this over here, that whole amount, is 0.9821. 9821. Okay, so what I got to figure out is, well, how much is each individual part? Okay, well, I've already got this is this part, okay? So if the whole thing is 0.9821, all right, if I just take that away, this 0.3015, okay, that means that middle is 0.6806, 0.6806, okay? And then if I wanted to figure out even this side to the right of it, all right, I can do 1 minus 0.6806, okay, and then minus 0.3015, all right, and I get 0.019, okay? So that's all the probabilities. Now, we're going to look at the question. What does it say? All right, less than 300, which would be this one, greater than 400, okay? So if I add those two together, all right, okay, continue where I left off, that I want to add those two together, and I get 0.3194 is my final answer to that problem. Okay, what would you need to get on the test to be in the 60th percentile? Okay, so what that means for me is that I would need to have 60% over here. I need a probability of 0.60, okay? I need a probability of 0.60. So if I look on my chart and try to find where the probability is 0.60, the closest one I can get to that is a z-score of 0.25, okay? So that the z-score is 0.25, all right? My mean in these examples is 320. My standard deviation is 38. So the way I solve that is I cross multiply, okay? I'm going to cross multiply, all right, 38, all right, and I'm going to add 320, all right? So my score is about 330, all right, would put you, all right, in that 60th percentile. Okay, the length of the replacement is normally distributed with a mean of 25, standard deviation 25. Find that the wiper blade is randomly between those lengths, okay? So I got to get 24.89 and 25.11. I'm going to do the z-score over here. 0.89 minus 25 divided by 0.2, okay? So my z-score is negative 0.55 for this side. Okay, so what that tells me, if I go to my chart, negative 0.55, that the probability to the left is 0.21 or 2912. To do this one over here, okay. All right, 25.11 minus 25, okay, divided by 0.2. That's going to be 0.55. Okay, on the positive side, and 0.55 will tell me that all the way over is 7088. Okay, so if it's all the way over, okay, I can find that probability very simple from subtracting. Okay, so 0.7088 minus 0.2912. Okay, so that tells me that my probability is 0.4176, okay? And to figure out the other one, I can do the subtraction from 1, because they all have to total up to be 1. And that's 0.29704. Okay, probably just need a 0 there. All right. No, that's not right. Yes, that is right. Okay, so find the probability the wiper blade is between those. All right, that's the one I'm looking for right there. So that's my answer. From a batch of 200, how many would be expected to be 225.3 or more? Okay, well let's find the z-score there. Okay, 25.3 minus 25 divided by 2. No, I'm sorry, divided by 0.2. All right, I get a z-score of 1.5. Okay. All right, so if I wanted to figure that out, 1.5, it's going to be 0.9332 on this side. Okay, to figure out the other side, all right, I got 0.0668. Okay, now it says 200 wiper blades to be more, that's this side, so I multiply that by 200. Okay, so I'm going to multiply that by 200, and it's going to give me about 13 wiper blades would be my answer. Okay, all right, the time taken by a garage to replace a worn out brake pad follows a normal distribution of 90 minutes, standard deviation of 5.8. What percentage does the garage take longer than 105? Once again, okay, all right, if here's a 105, all right, I'm going to find the z-score, which is 105 minus 90 divided by 5.8. Okay, 105 minus 90 divided by 5.8 puts me at 2.58. On my z-score chart, 2.58 is 0.9951 for this side. For the other side, it's 1 minus 0.9951. That's going to give me 0.0049. 0049. Okay. All right. What percentage takes longer than that? That's this side. So to get the percentage, 0.0049 times 100 gives me 0.49%. That is the percentage. Okay. Find the probability the garage takes less than 85. Okay. So I'm at 85. Okay. All right. I'm doing 85 minus 90. Divided by 5.8, 85 minus 90 divided by 5.8, I get negative 0.86. Negative 0.86 will take me to 0.949. If I needed to find the other side is going to be 0.805. 8051. Okay. All right. And what am I asking for? I'm asking for less, so that's this side. Okay. So 0.949. All right, times 100. It's 19.49. Okay. What is the area of the shaded region? Okay. All right. What is the area of the shaded region? All right. If that's at negative 0.65. I'm going to guess here's the mean, okay? The z-score is negative 0.665. All right, that's going to be 2578 on this side. To figure out the other one, I'm going to do 1 minus 0.2578, and that's going to be 0.7422. Okay, use the diagram. Which curve has the highest standard deviation? Okay, the highest standard deviation is going to be the widest one. So that's going to be column D. Which one has the same mean? Which curves have the same mean? Well, these are going to have the same mean because that's going to be B, C, and D. Which has a greater mean, A or C? It's going to be C because it's further to the right there. Which one has a greater standard deviation, A or C? Okay, since this is wider, C is going to have the greater standard deviation. So it's all about the width there for those. Okay, on the axis below, draw a normal curve with a higher mean and standard deviation. Okay, all right. So I would draw something wider and then to the right. Okay. What are the 4 requirements for a normal distribution curve? mean equals mode equals median. All right, the area is 1. It's symmetric. Okay. And 60, a majority of the data, it follows the empirical route. All right, those are the 4. Okay. All right, this is the combinations, permutations. Your class is conducting an election for president, vice president, treasurer. There are 150 people in your class. How many arrangements? So there's 1, 2, 3, 4, 5. So it's 150 P5. Okay, because the key word is I got to get those. Okay. All right. So I go to option. All right, over to probability. Whoops, to probability. 150 P5. Whoops, it's P8. All right, and I get a big number, 7.09 times 10 to the 10th. Okay. At a cattle cutting contest, the rider must separate into cows into groups of 6 cows from a herd of 50. How many groups could that be? That's going to be 50 C6. 50 C6. That's going to be 1589. 0700. I believe that's what that number said. Yep. I have 7 different fruit bars to last week. How many different orders can I eat the bars? All right, that's going to be 7P1. Okay, because you're going to eat a bar a day. All right, so 7P1. All right, that's going to be 7 different ways. Actually, I'm sorry, 7P7. Okay, because you're going to eat all the bars. Okay, that's going to be 7P7. Okay, so you can eat them 5,040 ways. Okay, all right. A game has 8 colors and 8 different cards and 3 colored chips. The player is dealt 4 cards and chooses one of the chips. Calculate the number. So I'm going to do 8 C4 for the cards and 3 C1 for the chips. Okay, so that's 8 C4 is 70 times 3C1 times 3. You multiply those together, you get 210. A model home offers wood, tile, carpet, floors. There are 20 shades of paint for the walls and 5 styles of lights. How many different rooms? Okay, so you can offers wood, tile, or carpet. 20 shades of paint. All right, how many different possibilities? So basically with the first one, you got a 3C1 for the type of floors. All right, you have a 20C1 for the paints and 5C1 for the lighting. Okay, all right. All right, I believe that's going to be 3 times 20 times 5. Okay, that's going to be over 300. Okay, all right. Okay, I'll just double check that with 20C1. I just want to double check it. All right, that's right. Okay, in a lottery, 5 distinct prizes are allocated to 30 participants. How many different winners can there be? That's going to be 30. Okay, P5. All right, because they're distinct. All right, 30. All right, P5. And there's going to be a bunch. 171 00720. I believe that's the number. And we're done. Okay. So that was a lot with the stats. Make sure you know how to use the Z-chart. Okay, just work on that. Understand that all those probabilities have to add up to 1. That's key.